Hello and welcome to the CyVerse Focus Forum webinar series. I'm Tina Lee, CyVerse's User Engagement Officer. Today's webinar is our final one of the Spring 2020 season, and it's titled Get a Taste of Orange, an Intro to Data Mining and Machine Learning, presented by Dr. Francesca Vitali, a Research Assistant Professor at the Center for Innovation for Brain Science at the University of Arizona. For those of you who may be new to CyVerse, we are a cyber infrastructure project funded by the U.S. National Science Foundation, and this free webinar series is designed to fulfill a part of our mission to train scientists on how to use CyVerse's computational resources. So first, some light housekeeping before we start the webinar. Today's presentation will be different than our usual format, as Dr. Vitali welcomes questions during her presentation, so we may go a bit longer than our usual 30 minutes. Please keep your audio on mute to minimize any background noise and only unmute to ask your question. You may also type your questions into the chat window on Zoom, open that up if you need to, and Dr. Vitali can answer those after her presentation. Her slides and the webinar video recording will be posted later today on our website webinar page. Currently, CyVerse is tweaking our training materials and events towards remote learning to reach our community during the pandemic, but also to better serve educators and researchers who may be seeking materials and resources online whenever they hit a technical barrier or reach an educational milestone. So please watch our website for more information on our virtual learning resources. And now I am pleased to introduce Dr. Francesca Vitali. Dr. Vitali received her PhD in bioinformatics and biomedical engineering from the University of Pavia in Italy. Her postdoctoral research involved developing methods to fuse biomedical and genomic data to investigate therapies for complex diseases. Currently, Dr. Vitali applies her formidable research and bioinformatics skills towards applications in drug repurposing and automated biomedical image classification for precision medicine. A highly experienced trainer in teaching both researchers and students in how to use Orange, I am honored to introduce Dr. Vitali to present our final webinar of Spring 2020. Hello, Dr. Vitali.
Hello, hi. Thank you, Tina, for the wonderful presentation and also to give me the possibility to do this webinar. So let's start. In this presentation, in this webinar, actually, I'm going to talk about Orange a little bit. And Orange is an open source toolkit that has been developed by the University of Ljubljana in Slovenia. And it is open source and is not commercial, so everybody can download it. And it allows to perform data visualization, data mining, and also machine learning without requiring programming skills. And it has a nice and easy visual programming front end that allows to perform this operation quite easier. And I started using it in 2010 during my bachelor degree. And since then, it changed a lot. As you can see, now we can do way more complex workflow and analysis. And since then, I've been always using it for pre-processing or to start visualizing my data and better understand what kind of deeper analysis to do. And I think that Orange is very useful for these things. And in this webinar, I'm going to do an overflow of Orange, so how we create workflow, and example of data exploration and machine learning. Everything is going to be basic because I don't know the level of the attendee of this webinar, so I'm going to keep it very basics so everybody can understand it. For sure, Orange is provided by CyVerse and with all its advantages, and you can use it in there. And when you download Orange or when you open it, you will see these windows. And on the left of these windows, you have categories, okay? And these categories are, for example, data visualized, evaluated, and supervised. And in each of these categories, you have the widget that you can use to perform operation on your data. On the right side, inside there is the canvas, so the white space where you're gonna drag your widget and put them in communication in order to construct the workflows. Okay, so now I'm gonna switch to an interactive like example of how to put in communication and how widget communicate in Orange. For example, if here we can see that we have the category that I was talking about, data visualized and model and unsupervised. And here we see that we have the widget. We can drag, for example, the file widget and the data table widget on the canvas. And we can see that the file has one kind of parenthesis, and instead the data table has two parentheses. This means that the file table has only outputs. Instead, the data table widget has inputs and outputs. Okay, the file data, the file widget, if you open it, allows to upload file that can be on your computer, also URL from, I don't know, Google Sheets and internet. And Orange provides a preloaded data set. For example, if we upload this heart disease data set, we can have a summary directly of what are the column names of the data set. In this case, this data set is about heart disease, and it includes 300 patients, of which we have age, and it says like the type of this feature. So it's numeric, we have gender, and then we have this last category that is this last column, that is the diameter narrowing, that actually is the fact that if the patient has or not has a clogged artery. And this is the target here. We see that for all the other column is featured, meaning that the other column are considered as a feature of your dataset, while the diameter is considered the target, so the class. And in this case is 0, 1. So 0 if the patient doesn't have a clogged arteria, and 1 if he does. Okay, so here you can see that you already have a summary of your data, and for sure if you want to make like prediction or other operation, you can modify the role here. Then you can send this data to the data table by dragging a link, and then you see that you're gonna see this data in the data table. And here, so you have the class, the age, and the gender. As we saw, the data table has also one output. This means that if, for example, you drag another data table and you communicate these two, you see that now you have a drag line, and it says selected data goes into data, the input of this other data table. So if we open that data table, now it's empty because we didn't select any row in this other data table. But if we select them, we see that it's going to change. So we are actually sending data across these two widgets. And this is very useful. And a lot of widgets allow to do that, even like graph or plots allow you to like upload, to like select a piece of data and then send it out to visualize, to save it, and to do other operation. So this was how the widget communicates. Then for sure you have a lot of different type of widget that Orange provides. And for example, the data category include the widget like the one to upload the file, but also you can perform operation on the file, like select column, drop column that you're not interested in too. And also you can perform queries with the select row widget. And so you can, for example, if you're just interested in selecting only female or a specific range of value of one variable, you can use these select rows and allow you to perform like query even on your data. Also, there is the possibility, if you are a programmer, to upload a Python script and use it in your workflow. And the visualized category, instead, it contains widgets that are for like visualizing your data. So the most common plot like box plot, distribution, and scatter plot, but also more advanced visualization like mosaic display that I'm gonna show you now in one example. So we're gonna still using the heart disease dataset. And it's here. For example, we can, in the visualize category, as I said here, we can drag the distribution, and the box plot. And we can directly connect them to our plots. Okay. For example, here, distribution, we can see, is still the heart disease data set, we can see the female and the male distribution in each of the class. And we can see that we have way more male that have a clogged artery, okay, compared to female. So that may be interesting in like exploring more in detail, like this male subgroup. And we can directly, as you see when I click that it changed the color, select the male. And so intuitively, if we are gonna like connect a data table from the distribution, we can see that the selected data in this graph, in this plot, are directly sent to the data table. And here we can see, in fact, that we have the male. Okay. Here we can see that the columns are split by the diameter narrowing. So we have the class, and you can look also at all the other variables. You can show the distribution, the cumulative distribution, or like you can decide to stack column. You can do other operation on your plot as well by clicking on these like checks. Also, for example, another plot is the box plot, as I think the majority of you knows is done, for example, for exploring your data. And here we can see that we can choose our variable to visualize. And in the first panel here on the top left, instead in this subgroup panel, we can decide to split in subgroups. And if for only the categorical number, for the categorical variable, okay? And we're gonna see why. So in this case, I selected the class that is 0 or 1, and you can see here. And we can see the age, how it varies. We have the median, the mean, and the quantile. And we can see that clearly the class 1, so the patient with clogged artery, are older than if compared to the other one. And we have also the results of the student test here. And we can change, and we can see female and male instead of the diameter narrowing here in the subgroup. And here we see that we have female are older than male. So it means probably that they survive more, and they have they go like these clogged arteries when you get older, if compared to male have before. So these tools are very interesting to do like easy explorative analysis. And as you can see, you can also do perform more complex visualization, for example, with the mosaic display here in the visualize. If you connect the mosaic display, these allow you to compare more than 2 variables together. Okay, for example, here what I selected is the chest pain that is on the axis here on the x-axis, and we have asymptomatic in the first column, and then the rows are male and female gender here. And we can see what is the proportion of the class in each for each condition. By clicking, we are selecting, so we can send again this data and we have the statistics if we just scroll the mouse on it. Okay, and these type of visualization allow to add other variables, so you can visualize further variables. And for example, here you can see that there are no female with this non-angine chest pain, and there are no female that have clogged artery with that type of pain, with that type of chest pain. So this may be interesting to understand better, and this variable maybe is good to be investigated more. So these are other type of operation that you can do. Okay, so these for which concern the visualization. There are other more complex widgets like Freeviz is very interesting too, but I don't have the time now to show, but they are very interesting to explore. So, and for sure, another the other categories that are provided by Orange are on machine learning. And these categories are divided in unsupervised and supervised. And this widget allows to perform you like machine learning, to perform machine learning techniques on your data. And the unsupervised methods, for the one of you that don't know, are called unsupervised because they find this model find a hidden structure in the data without using the class. Okay, so what that means is the fact, for example, that in the heart disease data set we have the clogged or not clogged artery is not going to be used by this algorithm. But what this algorithm does, they find subgroup, for example, of patient based on the features that you have in your data set. So I don't know, based on the age, based on the values of the cholesterol, and they don't use the class, okay? And a typical and probably the most common unsupervised method used is the hierarchical clustering. So the hierarchical clustering is used to find subgroups in the data set. And I'm gonna show you how it works. So we can delete the widget, just dragging and delete. So the zoo dataset is still provided as one of those preloaded datasets that you should have with Orange, and it's here. If you don't want to choose like preloaded datasets, you just change here the folder, and if you click on this tab, it shows all the possible type of file that Orange allows, and they are mainly the most common one, like Excel sheet, CSV, tab separated, mainly all. So now we are selecting the zoo dataset, and here we have 100 instances. And let's see what we have in our data with a data table. So it's this one. We see that we have all the animals and their characteristics. So if they have hair, feathers, and also we have the class here, that is the type, so the species, if they are mammal or invertebrate. So what we want to do here is to find subgroups, if we are able to find subgroups, similarity between these animals, and see if this similarity corresponds to the species. Okay, so if we use clustering, is gonna find subgroups not considering the class, but considering these features. And then we can compare them to the class. Okay, so how a clustering works is that it finds the clustering is based on the computation of the distance. Okay, so for example, you have, let me see if I can draw. Okay. Okay, for example, if you have your sample that are like one here, one here, one here, and one here, one here, one here. So here, for sure, you have two groups that are well separated, and the clustering should find those groups. So the clustering builds this cluster by computing the distance between each, let's do it a little bit, between each sample that you have in your data, and this distance is, for example, the Euclidean distance, and it computes the distance, and it starts like pulling together in the same cluster the most closest, so the closest samples. So for example, this one will be one cluster, and it is an iterative process that works with that in that way. And so it's going to compute the distances between all these samples, and therefore to apply a clustering, if we go in the supervised in the supervised category, we need to compute the distances before applying the clustering. Okay, so we send our data to the distances widget. If we open it here, we can see that we have the distances computed between rows. That's what we want, so between our samples. And then it provides also different metrics. The one we want to select is, for example, in this case, is the Euclidean. And then, so we can send the output of this widget. So the distances to the clustering. And if we open it, actually, we are going to have the clustering, okay? And here you're going to see that you have the clusters, like how it is constructed, the clustering, and you can select on the top here. So I'm going to answer the question later. And now what I wanted to show you is that you can select here on the top a threshold for which you can have more specific or less specific clusters. You see that in this case, if we set the threshold here, I have this type of clusters, okay? And this seems a pretty like reasonable threshold in which we have a cluster. And we can see that actually all the mammals are grouped together here. The amphibian here is a little, you have a little bit of characteristics that are probably similar. And then here we see that we have all fishes and one reptile. So maybe it's interesting to explore who is this reptile and why it has like that characteristics. So we can add the data table after the clustering to investigate these animals. And here we can see that we have all the fishes together, and the reptile that has been clustered together with them is the sea snake, probably because is correct, because probably it has a lot of features that are similar to the fishes. And again, if we go back here we can see that we have these mammals that are kind of separate in a separate cluster if compared to these mammals. So it may be interesting to see who are these mammals that are different from the other one. And here again, we can see that we have dolphin, seal, so they are like sea creatures. So they're still mammal, but they're kind of different, probably because they have like the different characteristics. So we saw that like performing like an unsupervised machine learning method such as the clustering allows you to identify subgroups in your data. Okay. Okay, I'm gonna close. And on the other hand, we can use also supervised machine learning models. And these models instead allow you to do predictions, okay? So if you wanna, for example, have, like in the heart disease data set, if we have a new patient coming in and we wanna predict if he's gonna have or not have like a clogged artery based on past data, we can apply one of these models and then see, and then by applying these models, we can predict, we can have a prediction on what is going to happen. Okay, if they're going to or not going to have the clogged artery. Okay, so to apply supervised machine learning, I'm going to show you one of the most common, that is the tree. Okay, and we go here. And I'm going to give you an easy example for better understanding how a tree works, because I don't know how many of you know. So we can use another data set that is already uploaded. It is this sailing data set. So you have also data set in this like data set widget, and you can look for them if you want to try play with orange. And so the data set, then we can apply the tree. And visualize the tree. Okay. Let's see what we have in this data. If we look into the data table, this data set is about a sailor that wants to know if he should go or not go in sailing based on past data, so based on what was the weather, the company, and the sailboat of his previous days. Okay, so here we can see that we have the class that is sailing, yes or no, that is going to be used in this supervised method, okay, model. And if we open the tree, this is how a tree looks like. So we have the leaves and the branches. And what a tree does is start identifying the most informative feature of the one that we have in our data set that can split the class, okay? So in this case, we see that we have company, and and we can see that on the right side of this tree, you have the red is more the color that is more on your leaves. This means that if the company is big, as is signed here, the sailor is always, you have yes, yes, yes in all these leaves. It means he's always gonna go to sailing based on our prediction, okay? And this is the most informative feature is identified based by computing the probability of that feature on the class over the class. So you have different index that can be used. I'm not gonna go into the detail to build the tree, but what it does is it finds this ranking index, find the most informative feature. Then once the most informative feature is found, it goes on into analyzing the other ones. And it seems that if the company is medium or no, it is gonna look at the weather. So if the weather is raining 100% of the time, for 100%, so it's very sure, it's not gonna go, so you're not gonna go. On the other hand, if it's sunny, you may go or not go depending on the size of your sailboat. So this type of we can see how this can be very useful, for example, in medicine. If you have a decision tree for, as we saw before, the heart disease. So this type of supervised algorithm can be very useful. And for sure, when we are performing machine learning supervised, what is very important is that when we build our model, we need to build it in a way that is generalizable to new data, okay? Because sometimes if we build a tree, for example, on our data, it may be too specific for the data that we are analyzing, and not if we are having new samples. So to show that the model is stable to new data, so it performs good, we need to perform an evaluation. And typically this is done by dividing our data set into training and tested, as is shown here. So the training set is the set of data that is gonna be fed to the algorithm on which is gonna learn. And then the prediction, we can use, and then we can use this, once this model has been learned, we use this model on the test set, and we can compare the prediction of the model to the real prediction, so like this one, okay? Let me know if you have a question and something is not clear. And so once you can, so in this way you can measure the performance. When you are performing machine learning, what is very important is to know is to have enough data to divide between training and test set. And this is there is a lot of literature on that too. But typically, what you want is to have at least 10 times more samples than the features that you have to perform this division in training and test. There are different strategies that you can use to evaluate your machine learning. One is to divide your data set in 70% training set and 30% of test set. Another possibility is to use the cross-validation, and the cross-validation is a model, is a method that divides your data set in 10-fold. Then 1 fold is used for training, for testing, and the other 9 for training. And this 1 fold, since you're dividing in 10, is always different 10 times. So you perform 10 times this validation, and then you have the average performances. And this is for sure more stable because the data set is always different and independent. For sure, Orange provides widget that allows you to evaluate the models with several models together and decide which one is the best for your data. Here is an example of a workflow. We have the file in which we are sending the data to this test and score widget. And then we have here as input to this test and score these supervised models. And then we are with this test and score widget, we can compare the performances of all these algorithms. And this is how the test and score widget looks like if you open it. And you can select what's the type of validation you want to do. In this case, we are doing like cross validation here. And this stratified, what is very important is to do a stratified cross validation because you want to keep the proportion of one class the same in your training set, you know, in tests for sure. Because if you have like unbalanced classes, so you have way more like, always referring to our data, the heart disease data set. If we have way more class 1, so clog arteria, we should replicate that in our training set to be consistent. And so the test and score automatically apply to our data, divides 10 times into training and test. And then here on the right side, you can see the performances of the 5 models that we want to compare. And here we can see that the naive bias, for example, has higher accuracy and area under the curve. You can see also the precision and the recall and all these other variables. So we can see that Orange allow you to perform like easy machine learning without even programming. What is very important is that you need to know what you're doing, and I don't have the time to explain in detail all these models, but you should have an idea of the mathematics as well. And if it allows like this test and score, if you attach, for example, you can also, the ROC curve analysis, you can also visualize the performances. And for example, this widget, the ROC analysis, show the ROC curves of your models. And for example, here on the x-axis, we have false positive that are the prediction of the model or that has been mismatched for the target class that you select here on the top left. And on the other hand, you have the true positive on, so actually the one that have been predicted correctly of this class. And ideally, what you want is that your model is, the best model is one that reach the top corner, okay? So this is like, I showed you a little bit how you can use Orange and to perform also machine learning and data visualization. There are other categories and widgets that can be added to Orange. And these categories include, for example, image analytics. This image analytics category allow you to perform deep learning on images, for example, find group of similar imaging. And like in this case, where it's been performed a clustering based on a group of images regarding animals, and we could see that the cows were grouped all together. Or another interesting additional category is the text mining. Text mining allow you to perform like text mining of like Twitter, and you can see the most cited words, but allow you to also perform you can also use PubMed there and perform queries, and then visualize the most used word in the abstracts. And so to do a little bit of like pre-processes of the test with the text mining. And to add these categories is, you can go here in Orange. I'm going to show you now. Like you have options here, and you have add-ons, and you can select, for example, I'm going to select image analytics, as I said, and text, and I can add them. So is installing them. Okay, and then it should ask once it's finished to install, how to restart Orange. And once this is done, I'm gonna wait 1 second more. You should see the category added here. Let's see. Because, okay, so you can restart Orange and see the new categories. Another option that you can have is to, if you're interested in developing a widget with a feature that you want, Orange on their website, they provide all the tools to build a widget. Is typically is all done in Python code, and so you can build your own widget, and also you can use directly Orange with their Python library, and so program directly without using like the front end. And I do that also a lot because they provide very good function for machine learning and data visualization. So let's see if I can restart Orange now. And I can show you that we should have the new categories. So here now you see that you have image, analytics, and text mining. So you have all the widgets regarding that. So you can look at the New York Times, look at Twitter, and perform like text mining on those, for example. So I think I gave you a basic overview of Orange and what you can do with this tool. I find it very interesting and very powerful for preliminary analysis. And saying that, I thank you, and let me know if you have questions.
Thank you, Dr. Vitali. There is one question in the chat.
Yeah.
Let's
see.
Yeah, did you want to open your chat and just see if you can address that? Otherwise, being from CyVerse myself, I can find out the answer for this person and get back to them if you don't know the answer. And they responded, James Herrick, yes, this is all the webinars are recorded and you can find them on our website later on today. So the question was about you're using the desktop version, and they were wondering about an HPC version perhaps from GitHub to use in CyVerse Vice, which is the visual interactive compute environment.
Mm-hmm. I think Orange is already in CyVerse.
It is, yes. And the nice thing about that too is that, you've shown us the data sets that are preloaded as sample data sets, but with the benefit of CyVerse is that your data are where your compute is. And so by pulling up Orange, you can do cool things on your data that you've shown us. Les is asking size limit on the data files that can be analyzed. Is there a file?
So you can upload also big data files like gigabytes, but I know that there is also a big data widget that Orange provides that you can look more into that, that is specific for like huge data.
Wow. Okay.
But it really depends on also the analysis that you are going to perform, because you can upload the data, but maybe like if you want to do deep learning on them, then it's going to take a while, but it would to use like Orange, but it's going to probably take a while even if you're using it on your computer.
Okay. There's another question. Does Orange have to run on CyVerse, or can it run offline on this person's computer?
No, I have it on what I show you now, I have it on my computer. You can just go on the website and it's free and you can download it and use it as it is. Or you can, yeah. I know that they are saying, yeah, it's available also on the HPC through Anaconda, and it's public, so you can download it and use it on your computer. I do that all the time.
Mm-hmm. Is Orange considered an app in CyVerse? I had a quick look and didn't find it, but I'm not very good at with CyVerse. I'll have to check on that. It might be listed under tools, or that you would just upload it. But we'll check on that for you.
I have these, I don't know, I'm gonna show you, it should be, I'm gonna reshare here.
Mm.
I have this screenshot. Let me share again. Okay. Here, I see that it's in the app, my public.
Public apps, okay, right. And so I believe that's in Vice too then. Somebody asked, are there specific format requirements for the data?
So you can see here that typically all the format are available here. Like if you look in the file widget and here you click on this folder, little folder, then you have all readable file and then you have all the extensions that are accepted by Orange. But you have, I think the most common like tab, even like zip file, Excel file, comma separated file. I think that the majority of them are available.
My question is for you, what does an error look like in terms of you have the drag and drop to create the workflow, but what will it tell you if you've somehow mismatched your widgets so that you're doing something wrong? Will it give you
so you're not allowed to connect two widgets together if it's not possible. Okay, like for example, let me see, if I have like a model, a random forest here, and I wanna, I don't know, let me see something that we cannot do. I wanna do a scatter plot probably on that. I cannot, depends. You see, I cannot really,
it won't even let you,
yeah.
So,
I cannot, it's not attached, yeah.
So it trains you, the user.
Yeah, exactly.
Okay, because somebody.
And another thing that you can do here, when you click on each widget, you have a question mark here. And if you click on that, it will open an help. And it says to you what are the inputs and the outputs, and a little bit what you can do with this widget and some examples.
Okay, because somebody asked about a tutorial to follow before they do their own efforts on Orange, but it sounds like there is in-app support there for you to read up about what your inputs, outputs, things like that. Okay. I'll post maybe some of this chat along on the website too, because people are asking about the links where to download Orange and
yes, it's just, if you just Google Orange Biolab, you are gonna directly go into the tool and you can download it here.
Okay. All right, are there further questions for Dr. Vitali? If not, thank you so very much. That was helpful and fun in my view. So thanks for that introduction to Orange. We'll be posting your slides and video again, as I said, on our website later today. We also have a YouTube channel. Just Google CyVerse YouTube and our videos are posted there. Again, please watch our website. We'll be posting later on this summer what our fall webinar series will look like, and that will start on Friday, September 11th. Dr. Vitali has already suggested maybe doing a follow-up webinar to tackle some of Orange's more advanced capabilities, because we just got a slight taste today. So thank you everyone for attending the webinar. Stay healthy, have a great summer, and we'll see you again in the fall.
Thank you.
Thank you.
Thank you, everybody.